So this is the Pearson Edexcel IGCSE Further Pure Maths specimen sample paper. It's paper number 2, which just like paper number 1 is calculator, which is ridiculous. But anyway, I've complained about that in every single one of these papers that I've done of this type. So let's just get into it anyway. Nth term of geometric sequence is this. Okay, let's just write out some of the sequences then, I guess. So if n is 1, that gives you the first term. Put n is 1 in, and you get 3e to the minus 1. Second term, when n is 2, you put 2 in, and you get 3e to the minus 3. Now, if that's the first term, and that's the second term, what do you have to times? Remember, this is geometric sequence, so we're timesing by something to get from each term to the next. What do you have to times this by to get to this? Well, it's going to be e to the minus 2, to lower this power down by another 2. So that's the common ratio between the terms. The first term is this. So when we get out our sum to infinity of a series, I've just noted here that 1 over e squared, which is what this is less than 1 and greater than minus 1, so I can sum this up to infinity safely. You didn't have to do that, but it just makes me feel better to know that I can. So this is the r, and this is the a. So we put those in, the r here, the a there. I'm going to actually write this without powers. I'm going to say this is a 1 over e, which I can then put down to the bottom, and this is a 1 over e squared, as I've already said. We can go here, expand out the bottom bracket, and then multiply top and bottom by e to get 3e on top and e squared minus 1 on bottom. And therefore b is 2 and a is 3, and that'll be my answer. Good. Question number 2. Okay, cool. Yeah, sure. This one, expand out, move the 6 over. Factorize again to find your critical values at 3 and negative 2. If you want to, you can sketch this. It's a quadratic that looks like this with values at minus 2 and 3 critical here and here. We want to be greater than 0, so we want to be over this side when x is less than minus 2. And we also want to be when x is greater than 3. So if it's greater than the number, you want to be having these two inequalities on the outside. If it's less than, then you'd be in between the two. That's the general rule. Express both this and this being true. To do these, it's not too hard on this one, but what I tend to do is draw a number line with all of my critical values on it, and 0, just to make me feel better. So the critical values are 4, minus 2, and 3, so I put all of those down there. Now, the blue inequality says that x has to be less than minus 2, so I'm looking for all of this, and also x bigger than 3, so all of this. The red inequality says x is bigger than 4, so all of that. And now all I'm looking for is any areas where the lines overlap. So x is greater than 4 is an overlapping area, there's no others, so it's just x greater than 4. Cool. Vectors question, as soon as I see vectors questions, I draw it, just because, and you can pretend these are coordinates. They are coordinates. The vector that goes from O to A is 4i plus 3j, so that's that. This is a coordinate here. I'm looking for A to B, which is this kind of arrow there, and apparently that length is 2 root 13. Now, of course, this is just Pythagoras, isn't it? Like so many things. We can express the height and the width of this little triangle. The height is 3 minus p. You can also do p minus 3. It doesn't matter which you do. And the width here is just 4, obviously, 8 minus 4. And so 3 minus p squared plus 4 squared equals 2 root 3 squared, 13, all squared. This, just be careful, is 2 times 2, which is 4, and then root 13 times root 13, which is 13, which makes 52 in total. You could expand this out if you wanted to, and recollect and rearrange and refactorize and stuff, but actually it's easier just to take away 16 and then square root. And remember, you just have plus or minus 6, so either 3 minus p is equal to plus 6, or 3 minus p is equal to minus 6. You get the answers 9 and negative 3, whichever one you do. Now here it says that p is greater than 0, which means p equals 9 is the thing that they actually want us to work with. Find the unit vector parallel to AB. Well, if p is equal to 9, then the vector A to B, it goes 4 across in the eyes, as we've already said, and then if p is 9, it actually goes 6 up from 3 to 9. So that's the vector A to B. The length of A to B, as we've already said, is 2 root 13. So if you're finding a unit vector parallel to A to B, you need this vector here, and you just need to scale it down by its own length. So that will be one way of expressing it. You could simplify it that if you wanted to, but it doesn't say so, so I'm not going to. Question number 4 is a doozy. It uses both factor theorem, which says if x plus 3 or x minus a is a factor of f of x, then f of a is 0. And it also uses remainder theorem, which I haven't actually seen before in these papers, but apparently that's on the spec. Remainder theorem says if x minus a divides f of x with remainder b, then f of a is b. Remainder theorem is actually just a more general case of factor theorem, because what is a factor if not dividing something with a remainder 0? So you could rewrite this as saying if x minus a divides f of x with the remainder 0, which is what a factor is, then f of a equals 0. So just replace the b's with the zeros and you arrive at this statement here. But in any case, what that means is that f of minus 3, a here is minus 3. Look, x minus minus 3 is x plus 3. So f of minus 3 is equal to 0 is essentially what this says. So put in a minus 3 into here, and that's equal to 0. You can tidy that up, and you'll get an equation in P and Q. And as soon as I see that, I'm happy, because that's the building block of a simultaneous equation that I can solve for P and Q. I just need to use the other information to make another statement. So f dashed of x, well, I need to work out what f dashed of x is first, so I'll differentiate to get that. Hope we know how to differentiate. And then if I put in minus 3 to this, I'm going to get 37, is what remainder theorem says. So substitute in minus 3, that equals 37. Tidy it up. And there's my second equation in P and Q. I think I times this by 3. Yeah, I did. And then I did this one minus this one, which gives you minus 9p. Minus 3q minus 3q goes away. 42 minus 51. Oh, sorry, 42 minus 51. Did I take away? So I should have added these together. Or did I do this one, take away this one? No, I didn't, because then that would be a plus 9p. What on earth has happened here? Hang on, how has this become a... That should be a plus 17, that should be a plus 51. Okay, I'm going to roll with this because I can't be bothered to re-record the last 5 minutes of my life. When I took away this 54 from here, that becomes a minus 17. But then I changed the signs here just to make it match closer with this. So this, actually, I times everything by minus 1. This should be a plus 17. This should be a plus 51. And then when I take away here, 42 minus plus 51 should be minus 9, which gave me the p minus equals minus 1. Sorry, equals 1, which is why I didn't notice the mistake, because I essentially made 2 mistakes and just ran with it to the answer. If p is minus 1, if p is 1, you substitute in there, and you get q is 11, and that would be my answer. So apologies for the mistake there, but I hope you can spot the mistake that's been made in here. If you can't, I mean, I've already told you what it is, but just spot the mistake in here and how it fixes it up, and how I get the answer. And we'll just keep going. Hence factorize f of x completely. So I know that x plus 3 is a factor. So I know this thing here equals x plus 3 times something else. I know that something else is a quadratic, because a linear times a quadratic is going to make a cubic. And I can just very easily spot that alpha must equal 2 to make the 2x cubed, and gamma must equal 4 to make the 12. So I can put those in, and now how do I find the beta? And by the way, as I'm doing this, if you want to just do polynomial division, feel free to. That's absolutely fine. It does work. I hate it, so I just always do this. How do I spot the beta? Well, over here I have 1x squared. How do I get x squareds by expanding this out? Well, I either get 6x squareds from these two, or beta x squareds from those. So 6 plus beta x squared equals 1x squared. And then so beta is minus 5. You put that in, and this is factorized with the x plus 3. How do I know whether this thing factorizes without just staring at it for ages trying to find something? Well, things only factorize if the discriminant is square. Like, because think about when you root in the quadratic formula, you root b squared minus 4ac. So if b squared minus 4ac isn't a square number, you end up with a surd, and then your answer is something that wouldn't have factorized nicely. So I need b squared minus 4ac to be a square. B is minus 5. A is 4, sorry, is 2, C is 4. Now, not only is this not a square number, it's not even a positive number. So I've actually answered part C as well. I've said this isn't going to factorize because this is not a square number, but also this doesn't even have a solution because this is not a positive number, or 0, which means when I root it, I'm not going to get a real number. And so this doesn't have any more roots. So the only root is this one here, which is at minus 3, as we've already said from the start of the question. So yeah, cool. Apologies for mistaking that question, but let's keep going anyway. In the formula booklet at the front of this exam, it gives you this formula. So that's fine for this. I've immediately got that just by looking at the booklet. Cos of a minus b. Now, I can essentially write that as a plus minus b. So it's essentially the same as this, but I replace the b with a minus b. So hopefully you can see what I've done there. This is the same as, imagine you're expanding cos of a plus negative b, maybe in brackets. You just put negative b's here. Now, this is where we use the fact that cos of minus b is equal to cos b, because it's called an even function when it does that. It's symmetrical around the y-axis, essentially. Sine of minus b is equal to minus sine b. That's called an odd function. It's not symmetrical. It is symmetrical, it's just symmetrical, and then you also have to flip in the x. So odd function, even function, odd function. Replace those here. So sine of minus b becomes minus sine b, so that negative becomes a positive. This just gets replaced entirely on its own. And so when we do this one, take away this one, we get this. So that's just this line, take away this line in brackets, remember, because that negative negative becomes a positive. So this adds to this to make two lots of them, and this cancels with that, and you get exactly what was required. Quite a lot of work there for 2 marks, but anyway. Hence express this in the form that. So look at this, look at this. They've just made A 5x and they've made B 3x. So, okay, we'll just put those into our little formula here, making A 5x, B 3x every time. Of course, we can simplify this to be 2x and 8x, and that'll be our thing. Integrate this thing. Now, this thing is basically the same as what they've given you here, but with x written as theta instead, which is absolutely fine. Did I completely forget to... Oh, I did. Excellent. Oh, who cares? I didn't remember typing any thetas, so I knew I'd made a mistake there. This is just 2 lots of this. So all we have to do is replace it with this thing here, but times it by 2. Now, I've just substituting in a dummy variable. This is worth knowing, actually, that you're allowed to just replace a letter with another letter when you're integrating, because it's not really going to make a difference when you integrate. Now that is true, except it's not really true, because this answer should still be in theta, because the question is in theta. What it's not going to make a difference for is this answer here, because when we substitute a number into this integral, as we're about to do here, when we substitute pi over 6 and 0, and those replace the x's, so my answer here is going to end up being correct, even though I've forgotten to put thetas anywhere. I think I'd probably lose a mark for this section for not bothering to write thetas. But I wouldn't lose the mark at the end here, because when you do this integral and you put everything in, you just end up with a number, because the numbers are replacing the variable anyway. Maybe I should be, while I was talking about that, maybe I should be more clear about what's going on here. Of course, cos integrates straight to sine, and then you divide by the thing in front of here. So 2 divided by 2 is just 1, and then 2 divided by 8 is a quarter. So that's where I got that from. Please remember the plus c. You don't need the plus c when you're doing definite integrals, because it will just cancel anyway. Sine of 0 is just 0, so all of this just doesn't matter. Sine of pi over 3, I've done exact values just because I like remembering my exact values. You could have just typed that straight into a calculator, and it would have given you this immediately, which I would suggest that you do in a real exam. But I was just being fun with it and making sure that I could do it with that one, because I think that's always a good idea. Anyway, question number 6. Really nice log question, this. Just very quick. Well, the question is very quick to write. The idea here is that to solve log equations, you always want log of the same base. So in the formula book, there's a change of base law, which says you can change this base to anything that you want. I've chosen 2 to make it match with this one. And then you put this number at the top of the fraction, log to base 2 of this number, and then log to base 2 of this number on the bottom. Now log to base 2 of 2 is just 1. And now I can times everything by log to base 2 of x, and I'll get this. So I'll cancel it with this one becomes a squared, and this one adds to there. And now when I move the 7 log x over, try and factorize this in your head. Now, if you're not so good at that, that's fine. Imagine the log to base 2 of x is just an x, and now maybe factorize that. And hopefully you can factorize that, and maybe that will help you with this one, because all I've done here is replace the x with a log to base 2 of x. So this factorizes to this, and so this factorizes just these x's replaced to log base 2 of x. It's worth getting that skill down. Anyway, this either means that either this is 0 or this is 0. Add 6 to both sides, add 1 to both sides, 2 to the power, and that. And the answer is 2 to the power 6, which is 64, or 2 to the power 1, which is 2. Good. Question number 7. This is called a rational function, by the way, because it's a ratio between 2 fractions. It's this over this. Sorry, between 2 functions, this over this. So it's called a rational function. Okay, so it crosses this point. Okay, this is the key information here to start with. That means when x is 2.5, y is 0. We can put that in there. And times everything by 2.5 minus b, and well, 0 times that is just that. So we get this, which means a is 2. Good, so that's the first bit. Find the value of b. So we have an asymptote at x equals 1. So when x equals 1, we don't have a y value. Like at x equals 1, which is some straight line here, there's no corresponding y value. The graph never gets to it. So when we put 1 into here, and remember we can keep the a as 2. So this is going to be 2 times 1. And I put a 1 here. How does this have no solution? Well, the only way is to have no solution is to be dividing by 0, which you're not allowed to do. So that means 1 minus b is 0, which means b is 1. And so that's that bit there. Find the coordinates where c crosses the y-axis. So things cross the y-axis when they're on this line here, obviously, which means their x-coordinate is 0. They're not going left or right, so their x-coordinate is 0. So let's put that into our updated function, which we know b is 1 and a is 2. 2 times 0 is, of course, just still 0. Minus 5 divided by minus 1 is 5, so that crosses the x-axis at 0, 5. Find the equation of the asymptote parallel to the x-axis. So there's apparently also a horizontal asymptote. So apparently for some y value that we put in, there is no corresponding x value. So what y value can you put into here for which you don't get an x value? Well, I'm put in 2, and try and figure out why this doesn't have a value. It's because when you cross multiply this and then take away 2x from both sides, you end up with garbage. So this has no solution, right? So the answer is the value y equals 2. Now, how did I know to use 2? Well, I knew that I needed to match up this x with this x, right? That's how you end up with no solution. The other way to think about it is, if you've got a horizontal asymptote and you travel all the way along it to like x is 1,000 or 1,000,000 or 1,000,000,000, and then put x as 1,000,000,000 in here, these two numbers essentially don't matter. You just end up with 2 lots of 1,000,000,000 divided by 1,000,000,000, which is just 2. And so 2 will be the thing that you need. Anyway, sketch this. So we've got an asymptote of y x equals 1 and y equals 2. That's what we already said. We know that it goes through this point, 2.50, which is on the x-axis. We know it goes through 50, which is or 0, 5, I should say, which is on the y-axis. It never goes through these asymptotes. Rational functions tend to look a bit like the graph 1 over x, because, of course, it itself is a rational function. So it looks a bit like this, never touching either of these lines, being kind of separated into its own 2 parts, like so. Question number 8, binomial expansion question. This, of course, can be written as 3 times 1 minus 2x to the power minus a half, because it's 1 over, so that's a negative, and then rooted as a half. Use the binomial expansion formula that's, again, in the front of the formula book. Please be aware of which formulas that you have there. N is minus a half, so look at the formula. N just goes there. This first gets used to the power 1, and then to the power 2, and then to the power 3, and then so on. We don't care about anything after x to the power 3. And then I've just used n minus 1 over 2 factorial, n minus 1, n minus 2 over 3 factorial, which is 6. And so, and again, just take each term one by one and type it into a calculator, ignoring the x's, because you can just say that's x squared, x cubed, and you get this, times out the 3, and you get that. Good. Write down the range of values for which this is valid. You just need the thing that's being squared or cubed or whatever each time to be less than 1 or greater than minus 1. So we just need this, divide both sides by minus 2, swap the signs over, or not swap them over, but change the direction of them because you're dividing by a negative, and you get this thing here, which is fine. Show this thing. This is only worth 1 mark. I think I made a bit of a hash of it, but I tried to rationalize it, right? So I times by this. Of course, 0.9 times 0.9 is 0.81, which I'm allowed to put underneath the root. And now I recognize that because root 81 is 9, root of 0.81 is 0.9. So that's cool. And now I'm trying to get a root 10 out of this, I can see. So this here is equal to root 10 times root 0.09, because 10 times this is just move the decimal point along. Now this here is, well, root 9 is 3, so root of this is 0.3. 3 times 0.3 is 0.9, which cancels with the other 0.9 to get root 10. I think I made a bit of a hash of that. There's probably a much easier way of doing it, but feel free to laugh at me if you want to. That was only worth 1 mark. This is worth 2 marks, and I did this much quicker because, of course, it's just GCSE maths. You times by the root plus the thing, rather than minus. It's called the conjugate. 1 times this is obviously just this, and then the whole point of this is that root 10 times root 10 is 10. This makes a plus root 3 plus 3 root 10 minus 3 root 10, which cancel, and then minus 9. That makes a 1, and anything divided by 1 is just itself. Easy. Hence, approximate this thing here. Now, we've got a bit of work to do. The first thing we can say is this thing we've already explained is the same as this. So that's the first thing we'll do. This is a really nice question because it just uses everything that you've done before, and you basically don't have to do any work at all. You just use all the things above. Root 10, we've already said is this, so replace that. And now this looks a bit like this. We just need 1 minus 2x to equal 0.9. Which it does when x is 0.05, and that's within the bounds that we mentioned earlier. So this is equal to this when x is 0.05, and this expansion we've already worked out is that, so we just need to put 0.05 into that. I put an approximately equal sign here because I've ignored the terms after this because I didn't work them out in the first place. They'll be very small because I'm doing 0.05 to the power 4 or 5 or so on, which is very small. Add 3 to the end because, of course, we've got this plus 3 still here. Type that into a calculator and you get that. Question number 9. Lovely question here because completing the square is probably my favorite thing in maths. rearrange it so I have it in this order, which I always prefer working with. Take out the -2 from just the first two terms. You can take it out from the 7 if you want to, but I never do. Just take it out the first two terms. Of course, the negative swaps here, so that's why that is there. Complete the square just on this bit here. So halve this from -1, take away the square of -1, which is still -1. It's always got to be the negative, of course. -1 squared is a +1, but always take away. And then re-expand the -2 into here. -2 times -1 is +2. Add these together and we'll get P is -2, Q is -1, and R is 9. I don't know why I wrote a 5 there. It's definitely 9. Whatever. The maximum value is the 9 here, because any x value that you put in here, x -1 all squared is positive, and then you times it by a negative. So this is going to be taking values away from the 9, because this is always going to be a negative number, except when x is 1, in which this is all 0. So the maximum value is 9, it happens when x is 1. The curve C has this equation, which we already said and looked at. L has this, intersects this, so we set this equal to that. Very nice and straightforward. It factorizes, you get these points. You substitute those in, preferably I would say to this one, though you should always check anyway, so substitute them into the more difficult one just to check. And these are my two coordinates. Good, the finite region is bounded, so we're doing a volume, an integration volume thing. Let's draw it just to make sure we know what we're looking at. This is the line 4 minus x. And this is this curve. I know it's roughly here because I've already worked out its maximum point is 1, 9. And now it intersects roughly here at -0.5, 4.5, and 3, 1. So I think this sketch is pretty accurate. I'm looking for this volume here. When I rotate this around the x-axis, I'm looking for the volume that this bit makes. So let's integrate this curve, which is the first one, between 3 and 1. Sorry, 3 and -0.5. Times it by pi, and of course square the function, because a volume of integration of revolution is pi times y squared, integral of y squared dx. That's y squared there. And then take away, you could do some kind of cone or frustum area here, but I just decided it would be easier to do the integral of it, to be honest. So take away that integral again, pi y squared dx. When you're integrating two things between the same limits, you're allowed to put them together. So I can put this -4x all squared into the same integral. And now, of course, I've just got this to do. Expand this out very carefully. It makes all of this. Expand this out. It makes this. Simplify. Then integrate. Then shove that straight into a calculator. And you'll get this answer here, roughly to the nearest integer, which is what they said. Right. Question number 10. Figure 1 shows the curve M with equation this. The point P with x-coordinate -2. So that's over here somewhere. Now, if x is -2, we can immediately find what y needs to be. So that seems like a good idea. So this is at -2, 6. So it must be in this section somewhere, at -2, and then some positive number 6. So maybe around here. I don't know. Maybe around there. Okay, so that's the point M. Sorry, no, it's the point P. M is the curve. It's the point P. L1 is tangent to M at the point. As soon as you say tangent, you differentiate. So let's differentiate this thing and find the gradient. Oh, I've actually estimated that the tangent should be here. So that's the point -2, 6, apparently. Differentiate this and put in the point x is -2, and we find that the gradient is -1. So yeah, this seems like a good estimate. Gradient -1. I want to find the equation of this line here, this tangent here. So let's say y equals -mx plus or -1x plus c. Put in the same point that you know that goes through at -2, 6, and find c. C is going to be 4 because this makes a +2, and you take away 2 from both sides. So actually, this line is not right, because c is +4, so it maybe looks more like that. Good, and that's part 1 done, I think. Part 2, point Q lies on M, and L2 is tangent at point Q. The two lines are parallel. So I'm looking for another tangent line to this curve that's parallel to this one. And the only one I can see is something that looks about like this, tangent at this point here. Just like this one is just off the turning point of this one is just off down here. So I think those two look roughly parallel to me. So this has gradient -1, because of course it's parallel. And I need to ask, where else does dy by dx equal -1 of the original curve? So of course I'm still looking for this to be -1. If we add 13 to both sides, divide by 3 and root, it's plus or -2. We already had the -2, so this is at +2. So this has x-coordinate +2. Find the y-coordinate by putting 2 into here, and we find it's at -30. So this is the point 2 -30. To find the equation of this line, we know its gradient is -1 because it's parallel to this one, and we know it goes to this point, so we do the same thing we did before. And we solve for c as -28, which looks like it makes sense. and we get that there. Good. Last few parts of this question. Find the coordinates of R if the normal, so to P, now P was the first point, so it's that one there. The normal to M is like this, making a 90-degree angle there. Now that of course means that the gradient of this one is positive 1, because the negative reciprocal of -1 is just 1. And it goes through this same point, -2, 6. So same thing we've done before, y equals +1 x plus c, we know it goes through -2, 6, we solve for c, and we say that's the equation of the line. Cool. Find the exact length of the line P to R. Now R is where the normal meets L2, which was this line. So we're looking for this coordinate just off screen. So we're looking for that coordinate there. So we just set this equal to that to find the coordinate of intersection, and we find x is -18, which we then put into either one of these. This is the easier one, of course. -18 plus 8 is -10. So this coordinate here is -18, -10. Find the length of PR. So that's, again, this length here. Now this coordinate is -2, 6. This coordinate is -18, -10. So we find the difference between the two coordinates, so -2 minus -18 and 6 minus -10. It makes more sense maybe when I put it like this, because this is just the distance between -18 and -2. Of course the distance is 16. The distance between -10 and 6, which is the y coordinate of that, is of course 16. And if you haven't seen this before, there's no need to square or root this. Of course, you've got a calculator, so you can do. But when you add up the squares of the two same numbers and then square root, the answer is always just that number root 2. It's a scaled up version of the 1, 1 root 2 triangle. This is the 16, 16, 16 root 2 triangle. So yeah, that would be my length here. And final question is asking me for the area of the rectangle when you do the same thing over here, draw a normal here, intersection with this line, and you get this rectangle here. What's the area of it? Well, we've already worked out that this length is 16 root 2, so all we need to do is work out this length, which is of course the same as this length, and times them together. So just do the same thing here. This is the point 2 minus 30, this is the point -18 minus 10. Find the length of this line, so it's going to be -18 minus 2 all squared, and then -10 minus -30 all squared. This makes 20 here. The distance between these two things is 20, between -18 and 2. The distance between those is 20. The difference between these is also 20. So this is 20 squared plus 20 squared, which you know is going to be 20 root 2. So we've got 20 root 2, we've got 16 root 2, times those together, root 2 times root 2 is 2, times by 20 is 40, times by 16, well, 4 times 16 is 64, so add the 0, 640. We now come to the greatest question of all time. Just an absolute banger. Just an absolute banger. A banger. You know, effervescence, bring me to life. This is the mathematical equivalent question to that song. Like, it's timeless. It's incredible. Just amazing. You've got a cone with radius x, height L, slanted height L, height h, slanted height L. You've got an angle ABC of 60, which doesn't change. So this cone is getting bigger, but this angle isn't changing. So the cone is kind of extending outwards down here. Like it's getting wider this way and taller, but this angle isn't changing. So it's kind of extending out like this. So this angle is 60, of course. That means this one is 30. And if I call surface area S, the total surface area S, then that means if it's increasing at this rate, then that means ds by dt is 10. Okay. Now, I'm looking for the exact rate of increase of the volume of the cone when x is 6. So I'm looking for dv by dt, the rate of increase of v, when x is 6. So I need to find dv by dt in terms of x, such that I can put x in and substitute it in and find it. Okay, so there's quite a lot to do. First, let's express the surface area in terms of x. So the total surface area of this is obviously pi x squared for the base times pi rl, or r of course being x, pi xl for the slanted surface area. Now L, looking at this triangle here, sine of 30 is x over L. So that means, well, sine of 30 is a half, for those of you who don't know that. Cross multiply and you get L is 2x. Substitute in 2x here and you get 2 pi x squared. Add them together, so the surface area is 3 pi x squared. Now I can differentiate that with respect to x. So ds by dx is 6 pi x, just differentiating. And now I can fiddle with these two things here, can't I? Oh, in fact, no, now I'm going on to v. I'll deal with this later. Let's go on to v. v is, of course, a third pi r squared h, where r is x, But again, I can do the same thing with this triangle. I can express h in terms of x. So I can say, actually, cos of 30, sorry, I said tan of 30, of course, opposite over adjacent. Tan of 30 is x over h. Tan of 30 is 1 over root 3, cross multiply, and then substitute that h into here to get this here. X times x is x cubed, root 3 over here. Good. Differentiate to get dv by dx is that. And now I've got ds by dx, I've got dv by dx. Remember, I want dv by dt. So let's mess with these, because this seems hopeful. ds by dt, I can say is the same as ds by dx times dx by dt, because these x's would kind of cancel and you just end up with ds over dt. But I know ds over dx, that's this, and I know ds by dt, that's this. So I can find dx by dt. And it might be, you might be thinking, oh, how is that helpful? Well, now we go to this, and we think, actually, dv by dx, I can write as dv by dx equals dv by dt times dt by dx, because the t's would cancel, and I'd just be left with these two. Okay, but I know this, I want this, I said that right at the start, and actually I know this, because I can just flip this over, and then I can put it in there. Of course, times both sides by 10, divide by 6 pi x. And there's my expression for dv by dt. I just want to know when x is 6, so I'll put 6 into here. Of course, pi times 6 squared is the same as 6 times pi times 6. So that cancels with that, and I'm left with 10 root 3, which will be my answer. Absolute banger of a question. Thank you for watching.